Uzi 9mm. Just kidding. Actually, it's ShinSung 9mm. Here we go. Oh, it's high. Definitely high. Much better. Still a little high though. Let's see if we can repeat that. Okay. Let's try the smallest one. Oh, that was a direct hit. Oh. I don't know if you can see that, but actually the right in the middle there's absolutely no yellow color anymore. Ooh, yes. I'm not sure if I have one more. I think I have. Maybe not. Oh no! I broke it off. Hey guys. So I'm going to do now a video that is actually kind of back to the roots of my channel. So it will be a video about modification I made to a certain airgun. If you're following my channel from the beginning, then you probably know that I've started actually with the video about Hudson BT65. And there will be another video about that gun as well in the future. But right now we will focus to ShinSung Career Ultra. Now, if you watched my video about my airgun collection, you've seen that, actually you've heard me say that this is actually my first PCP. And this is the first PCP that, this is the PCP that at the time I didn't have yet the any scuba tank at all. So I used hand pump to pump this gun. And of course, this is a 9mm gun, quite powerful. And you can imagine what is that like, about maybe 10 shots the most at the regular power, which is the way the gun comes from the stock set. And then you need to top it off to 200 bars from, I don't know, 140. And it's a half-liter reservoir. So I can say that I wasn't really impressed about the combination at the time. But of course, eventually over time, I got more guns. I got a scuba tank. I have a colleague who fills the bottles for me, and I have now also the boosters, so this got easier with time. Okay, so let's start with this gun. This is a rather old gun. I actually bought this one used, and it's a 9mm lever action repeater gun. It's quite well known, although most of them come in a slightly different shape, a slightly more common shape. This is slightly, I'm not sure what it's called, but it's not that often as the others are. So let me give you first some specification of what the gun did when I bought it and what it can do now. So at the beginning, it was designed to shoot pellets, Yungjin pellets, or later on JSB pellets, and it was shooting them at about under 150 foot-pounds, let's say 130, something like that. And it comes with this kind of magazines. You can load about 6 JSBs or Yungjins inside. You put them in here. So I will move this slightly around so you can see better. You move them, you put them in the magazine, and then you put it in here, and then you just cycle it like a normal lever action firearm. It gave about 10 shots from max fill, which is 200 bars. And that was about it. It was relatively accurate, especially I noticed its accuracy when the JSB came out, because they're way superior pellets than Yungjings. And after a while I wanted more and more from it, so I started to upgrade it. First put in a heavier hammer. Later on I tried to make some things that would not open the lock when you fire and things like that. We will get to that, because this is, let's say, some sort of, you could say, design flaw of this gun. And right now it's shooting at about 350 joules, so that's about 270 foot-pounds, with of course casts, no more pellets anymore. So mainly I shoot with those. So these are Slovakia-made bullets for pistols. So this one in particular is for 38 special, so it's slightly bigger diameter, so it's 0.358 of an inch, which is kind of the perfect size for this barrel. This barrel is actually not a standard 9mm, it's closer to 38 special or 357 Magnum. So this works better. I have some other alternatives. I have some that I cast myself with MP molds. This also worked quite great. These are 127 grains and some other. But anyway, these are, let's say, for the accuracy the best, and also give the most power, because this gun is now shooting them at 350 meters per second. That's about 830 feet per second with 158 grain. So that's about 270 foot-pounds of energy. Now this is a very decent and respectable energy, especially for a gun that is that has a fill pressure of only 200 bars. Usually these guns go to 250 and then you shoot them to about 200, but this one is limited with its pressure. Now, of course, to get this power, I didn't get it immediately because just putting a bigger hammer is not enough. I also enlarged transfer ports. I designed and made a pressure-assisted valve, which I will show you later. And I made an anti-bounce mechanism, and that in the end gave the results I have now. So I will just go through everything I did from the top down. First of all, I wanted to say that these mods that I did, this is only for my personal use. This is, you will see that this is definitely unique. It's not something that I would do for anyone standardly, because it's only for my use. That's basically it. So first of all, I have this muzzle cap, which is brass. This doesn't affect anything, it's just that I got tired to the black one. And I made a quick fill instead of the fill probe. It's slightly easier, but generally doesn't change a lot. In order for it to accept the longer bullets. Bullets are longer than pellets. So this is the original magazine and this is the modified. As you can see, there is a cut here. So longer bullets can feed into the this feeding ramp. And now let's open it up. I have a Picatinny adapters here. These are just for me to make it easier to remove the scope, because kind of a big downside of this gun, the way it is designed, is that you have to remove the scope in order to take it apart. And once you do that, be very careful, because on this side, let me turn it around, there is a spring for the magazine inside. You have to pay attention not to, so it doesn't fly out. So you kind of have to hold fingers here, like this. Yeah, okay. So let's put the stock away. Nothing special about the stock. Okay, the spring already, I think, fell down. Not sure where though. Ah, here it is. Okay. So this is the spring that is pushing the magazine forward and having it in place. Okay. So let's get right into it. So I will first zoom in, because you will need to see this close up in order to see and understand what I'm talking about. Okay. So this is the side where the magazine goes, and immediately you can notice that I had to make this larger. So this is made by me. So this cut inside, again, to accept longer bullets. To be able to feed. So this is the first mod, and this is, let's say, one of the easiest one. And after that it gets quite complicated. So nothing really major done on the top. So this is still the same procedure, same feeding. So this pushes this feeding ramp out, and then the bullet is pushed in by a spring, and then when you close it, it goes the other way around, and it closes and puts the bullet in the chamber. So top side, nothing really much changed there, but let's get to the other side, which is where all the additional things that were made are. And here it gets trickier. So first of all, as I mentioned before, I have a pressure assisted valve. So this is the valve stem, the valve is in here, and this rod in here is fixed with this pin, and that means that it is fixed. That rod cannot move anywhere, and the valve of course can. So this is me pressing on the valve stem. So let me take this apart so you will understand it easier. So here is the valve. So I changed the valve so that the valve is full metal piece, and over here is a plastic or a piece that actually seals and also enlarge a little bit the transfer port. It's now all the way through is about 8 millimeters. Over here it's actually 9 millimeters, because you have to deduct the size of the surface area of the stem as well. And here is how the pressure assisted valve works. So this is the valve, okay? And let me see if it's in focus, okay? This is the valve, and you can see there's a very small hole over here. Hole in here, and hole through this middle part. So there's a big hole and a small hole that actually vents through this very tiny hole. So the way that this works is that this piece that you see now hanging down, because it's flexible on this axis over here, is actually fixed inside, and it's going in and out through in this hole of the valve. And of course there's a seal over here on this part, on this pin. In the end there's a seal. I'm not sure if you can see this in here. And what happens is that this surface area of that hole is about 1/2 of the surface area of this hole, which is what the valve has to overcome. And because there is a vent hole in here, that means that in the valve, inside the valve, there is a seal on the other part. So in the valve, it's actually 1 atmosphere pressure. It's not high pressure. Everywhere else is full pressure, of course. That means that there's a pull force on that stem over here. It's trying to pull it in. And this is the amount of the force that you can deduct from the full force of the full surface area of the valve. So meaning if this is a 9 millimeter hole and this surface area is half that, meaning that you will only have to use half the force in order to open the valve. And it's not only that, it's also the fact that as soon as the valve is actually opened, you have a bigger surface area on this side of the valve, so this is already by the transfer port, than you have on the other side because of that small part size. So as soon as you open it, it actually wants to open it even more for a while. That is until the pressure rises in this valve because it is venting through this small hole. So as soon as this side of the valve is pressurized, so this is the side where the transfer port is and where the bullet is and where it's going to go through the barrel, as soon as this pressure rises, this high pressure also enters through this small vent hole in the valve, meaning that it will start to close it. So it will apply pressure. Eventually, if it would take that long, but it probably doesn't, the force would be the same to close it as it is on the regular non-pressure assisted valve. So that means that as soon as the hammer hits the valve, it has to hit it very little, just enough to open it, so that the pressure in this side of the valve, so the transfer port side, rises, and then it will try to open it fully, and as soon as it has time to vent inside the valve through this small hole, it will close it again. So this means that it's very efficient because there is very fast opening time, and holding there until the pressure builds up in the valve through this vent hole, and then very rapidly close it. The only downside is that with this design, it is very good that you have anti-bounce system, because the closing is very aggressive once it comes to it, and it is very likely that will bounce the hammer a lot back. So that's why I also have an anti-bounce system, in order to get a lot of shots, of course. Otherwise, I would spend too much air. So this is the idea. So fixed part is this stem inside, which takes up half of the force of the valve, meaning that this whole thing will be pushed towards the valve because there will be force on it, and this is how this works. Of course, there's a spring inside, and this spring is a valve return spring. That's it. So that is basically how virtually almost all my rifles have the valve set up right now. And as I mentioned, the downside is that you get more bounce effect, so you kind of need anti-bounce. And there's also, of course, a bigger chance of a leak, because you have an additional seal over here between the valve and this stem. Of course, additional O-ring always brings additional possibility of a leak. But so far, I must say that I didn't have any problems with this design, as long as this internal part is smooth enough and this part is accurately made in order for the O-ring to survive the forces. Here is a close-up look to the valve and the stem. So this is the valve, and this is this stem, and this is the seal on it. Here is the vent hole, and this is how this runs inside. So now that you've seen how the pressure assisted valve works, you can imagine that I need a lot less hammer weight and spring tension, so hammer spring tension, in order for the action to actuate. to work, so to basically open the valve. And now let's look at how the spring looks. So that's the spring. That's it. It's very weak. It takes almost no effort to cock it, and that was one of my main goals, because I hated the way it was made before, because you couldn't actually cock it like you are supposed to in the regular under lever gun, but you couldn't do it like this with these three fingers. You had to put your thumb in and then really use some force to cock it. Now, because this spring is so light, you can just flip it around and it cocks extremely easy. Second thing is the hammer, which is much lighter than it was. Actually is only about 40 grams now, so extremely light, because it doesn't need to be, again, because of the pressure assisted valve. Now the downside, as I mentioned, of the pressure assisted valve is that you get a lot of hammer bounce, and because of that I made a hammer bounce mechanism. Now this one is underneath here. I will try to take this off right now so you will be able to see it. So there are 3 pieces in here. This is about as much as I can open it and show it to you, because otherwise everything would fly off, because there are springs inside. So this top piece, and this is actually the piece that stops the hammer the second time it wants to hit the valve, so after it bounces. Actually, that's the piece on the back. This one actually stops that piece from going up before you take the shot. So I will just demonstrate it now without a spring. So I put the hammer in and I press the trigger to release it. So, okay. Now look what happens once the hammer reaches the valve for the first time. So it moves it away, this top piece, and once it goes back, that other piece in the back jumps out and stops the hammer from hitting the valve for the second, third, and etc. time. So this is basically a very simple operation, but there is an issue, because once it's in this state that it is right now, it cannot hit the valve again, of course, and you have to reset it when you cock it. And this is done by this small part here, which is connected over here to the main lever. So when I go back, you see that this part is moving back, and it's moving that piece down and away from the hammer. And then it's locked here by the second piece. So now it's down again, and the hammer can again hit, of course, as soon as I release the trigger, can hit the valve once, and then it's going back, and the second time it cannot hit it anymore. So I basically have this anti-hammer, anti-bounce design on virtually every airgun about now, because I modified all of them to have a pressure assisted valve, and also this mechanism that prevents multiple hammer hits of the valve. But probably on this gun it was the most challenging, because everything had to be so small, there's so little room, and of course you have to improvise. You don't know where you're going to have the room and ability to make any of these parts. So each gun has a different design. Actually, functionality is the same, but a different approach has to be taken to make something like this. Now this is, let's say now, I've explained a couple of very major functions of this gun to enable it to achieve higher power and also to be efficient with air. But now comes one of the greatest challenges and most important parts, modifications, which is the locking mechanism for the bolt. So if you take a look, over here inside on the top is the bolt. And the bolt is pushed back by under lever, of course, and then also returned back with an under lever. Okay, nothing special about that. But if you look at this mechanism, this has no locking mechanism. So basically, as soon as you close it, you have still this angle which means that this hits backs when you fire the shot, and because of the recoil, and it will actually try to open the underlever. And this actually happens sometimes even with the stock power version. And you can imagine if you put a bullet inside which has more friction, much more weight, and you're having much higher energy, that this just wouldn't work. It will always be open as soon as you fire it. So that's why I made this modification. So if you look at this part here doesn't only have a hole for this pin to go through. It has a slightly longer hole that enables for the lever to travel slightly back for a while before it actually starting to pull the bolt or the pellet pusher or whatever you call it back. And that is to unlock it first, because the locking mechanism that this gun actually now has is actually this part. So this part goes in here, so I have to open this, goes in here, and this actually locks. So this part, this is the pellet probe, slides through here, and once it's in the front position, it's locked here that it cannot move back. And there is a part here that holds that to which it presses against upon fire. And of course there's a pivoting hole here for the screw on which it pivots, because of course once you cycle it, it has to move away, and then this can go back. It's under spring tension, as you can see, and it has an axis down here, so it goes through here in order to pivot on that axis, and this is slightly protruding out in order for this part to push it away once you cock it. So if you look carefully, the bolt is not moving yet back, yet this part is already pushing away the locking mechanism. So right now it's fully away and the bolt starts to move back. Once you go forward, you will hear the click once this locking mechanism engages. That's the click, and this part jumps out. So again, the click, and now it's locked. Now the bolt cannot go anywhere. And this part has a recess that catches this bolt that goes through to the hammer. So it actually locks on this bolt, which is the strongest bolt of the whole, the strongest screw of the bolt mechanism. So that's the most reliable it can be. And actually that functions perfectly. Actually never ever had the lever open while I take the shot. And that is of course important in terms of safety, in terms of saving the O-rings. It doesn't blow off the O-rings, of course, and so that's a very important feature. Now this part that I removed before from the anti-bounce mechanism is there purely to hold it in place. So it's just a sheet of aluminum folded in that way that it holds everything in place so it doesn't fall out. And yeah, I think that's mainly most of modifications. There are a few of them that are much simpler. One of them is the trigger. The trigger was quite stiff when I got it, and I modified it. So basically what I did is here is the original axis, and I put it slightly forward in order to have more leverage, and because of this the pull is very light, and also because I made the hammer much sharper on this edge where it actually catches the lever from the trigger, because it's a simple trigger. It's a dual stage, but the trigger blade itself actually catches the hammer. There's no middle, actually there's one middle part that you move away and you can adjust that. So these are the mods. And with these mods, as I mentioned, I get about 6 shots from 300 bar fill, and they are quite consistent actually. The power is slightly dropping with each shot. Maybe the first one is slightly higher, and after that it's dropping. And if I want to shoot for some extreme accuracy, not to get that bullet drop because of the velocity drop, I use Humar external regulator. Now this is screwed on directly to your bottle or your fill station, and this can be adjusted to any pressure you want from, I think it's from 150 to 250 bars or something like that. I have it set to just 200 bars. And with that I get really consistent shots, and of course the accuracy is much greater that way than it is without it. As I mentioned, 6 shots. For that 6 shots I get without the regulator. I usually fill it up to 210, 215 bars, just over it a little bit to get the most shots and the most consistent shots. So that's it, guys. I hope you enjoyed the video. I hope you like the mods I made here. It was quite challenging at times and took a lot of disassembly and reassembly and things like that. Yeah, one more thing I forgot to mention is how the pellet probe works. Hopefully you will be able to see that if I remove this part. I will just put the latch out. Now I will zoom in. So over here, so not sure if you can see that right now, but right here we have the pellet pusher, or in this case bullet pusher, and it looks like a regular pellet pusher, but in fact it's not. And I will show you this in a minute. I will turn around so you can see it better on this side. So here it is. So you can see that the pin itself is quite long, but actually there is another feature about this pin. It's actually spring loaded. So for example, you see. So I did this because if you are using only pellets, then this isn't an issue, because you have to put the pellet in the rifling anyway. You don't have a special chamber for the pellet, you put it directly in the barrel in the rifling. But if you have a bullet, you can't do that because it requires too much force to do it. So this is why I have this spring-loaded pin, because each bullet is different in length, and you want to push each one up to the point where the chamber gets so narrow that it cannot move forward. So this is where this spring-loaded pin comes in hand, because it pushes every pellet fully forward and not just partially, as long as the pellet probe or pellet pin is. So quite an important feature in terms of accuracy. Only, of course, the gun would work just perfectly without it. And it also allows me to shoot pellets, although for pellets I have to make some extreme adjustment to have the power low enough for them to shoot accurately. So that's okay. That's, I think, really everything now. Yeah, thanks for watching. Hope you enjoyed the video. Please subscribe, click the bell button if you want to get notification of my newest videos, and see you next time.